Hello everyone. Welcome to today's lecture on exploring travel review data using unsupervised learning techniques. I'm the programming professor, and today we'll dive into a fascinating case study that demonstrates how we can extract meaningful insights from travel review data. In today's lecture, we'll cover several key topics that will enhance your understanding of unsupervised learning. We'll explore when to use different unsupervised learning techniques and how to apply them effectively. You'll learn how to use clustering to uncover patterns in your data, discover outliers that might indicate unusual behavior, and use principal component analysis to reduce the complexity of your datasets. Throughout the lecture, we'll be working with scikit-learn, one of the most popular machine learning libraries in Python. Let's start by looking at our dataset. We're working with a comprehensive collection of travel reviews from East Asia, containing data from 980 users. The reviews cover 10 different types of destinations, ranging from art galleries and dance clubs to restaurants and religious sites. What makes this dataset particularly interesting is that it uses a simple rating scale from 0 to 4, where 0 means terrible and 4 means excellent. One of the key challenges in working with review data is understanding and accounting for personal bias. Let me show you a concrete example. Consider a reviewer who rated 4 different restaurants, giving them scores of 4, 3, 4, and 2, resulting in an average of 3.25. The same reviewer visited 2 art galleries and gave them ratings of 2 and 1, averaging 1.5. This clear difference in ratings suggests a personal preference for restaurants over art galleries. Understanding these biases is crucial for building effective recommendation systems. Now, let's look at how we can use principal component analysis to understand the relationships in our data. This code demonstrates how to apply PCA using scikit-learn. After running PCA on our standardized data, we found that the first 2 principal components explain 42.5% of the variance in our dataset. Interestingly, we discovered strong correlations between similar categories, particularly between theaters and art galleries, and between parks and religious sites. Moving on to clustering, we can use k-means to identify groups of reviewers with similar preferences. Here's how we implement k-means clustering in scikit-learn. Our analysis revealed 4 distinct groups of reviewers, each with unique characteristics. We found that some reviewers consistently gave higher ratings to religious sites, while others showed a strong preference for resorts. Interestingly, 2 clusters showed particularly high ratings for juice bars. Finally, let's examine how we can detect unusual rating patterns using DBSCAN. This code shows the implementation of DBSCAN for outlier detection. We set epsilon to 1, which represents 1 rating level difference. This approach helps us identify reviewers whose rating patterns deviate significantly from the norm, which can be valuable for filtering unusual reviews or understanding unique preferences. To summarize what we've covered today, we've seen how unsupervised learning techniques can reveal hidden patterns in travel reviews, used PCA to understand relationships between different types of destinations, applied k-means clustering to group similar reviewers, and employed outlier detection to identify unique rating patterns. All these techniques contribute to building better recommendation systems. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.